Hi my friends, today we model this part, very nice, which has the name retention valve body. Dimensions are here and we will use them. The source is from Timoteo Carrera Soto. Of course, he was a Spanish engineer with activity around 1935 when standards were not so well defined, so that we have to create our drawing, and I work a lot for this, because I want to have modern dimensions and shapes. There is a small mistake here. You see, we have to model this object, yes? This from up to here. This is a dimension 50 plus 18. What is the sum? Is 68. The same end is measured here by adding 45, 26 and 7. You are free to calculate this and you will see that it is not 68, so that I ignore 45 here. Okay? Good. We start. We are applying certain strategy here. We create, let me present this. We create firstly this external revolution feature, then this external revolution feature, then internal, then internal. Always this is the right procedure. Dimensions are here 250 and a diameter of 235. Then 158, all these dimensions, radii, and the other dimensions. There is another radius 5 here. So we can start with this sketch. Standard millimeters, start sketch, 2D sketch, then we create the first sketch. I respect that shape, but at a small scale. Now I create an arc, a small horizontal line, this horizontal line, vertical, inside, vertical, outside, perpendicular, center point. This is the center point of our construction, of our whole work. I select the center line and close. You see, now we have that shape at a small scale. When I apply a major dimension now, but to be outside of this point, not from here, like this one, I apply diameter of 235 instead of 17, you see, 235, and now we have a homothetic shape based on what I made before. Oh, very nice. I place the height, which is 215, radius 15 here, then small dimensions like this one 16, this one 16. I created that drawing before, so that I remember dimensions here, and I like to speak while I make drawing, because you can have a better understanding of all things. Now, dimensions, diameters 158, 90, 98, 98, and this button diameter of 160. Fully constrained, that's all. Fully constrained sketch. And we see here a mark, yes, a point, a pin. This is a pin, which means fully constrained. Finish sketch, revolve, and everything is defined so that we have the first volume. I add now some fillets, as I mentioned before. 5 is here, also 5 down, 5 is here, and plus this is 4, not 5. 4. Okay. Good. We see here only names. If you want to have also data about that features, you can activate this option and display preferences, show extended names, not only name. Now you see revolution, new solid fill, full. And dimensions, where are dimensions? Dimensions are in the sketch. Then fillets of 5, which are 1, 2, 3. Fillets 4 millimeters, only 1. I'll maintain this option to have always an image of dimensions. Good. Now we create the sketch for the horizontal revolution body. We have dimensions here, diameter of 150, 90, radius 5, this is 16, 150 is twice, no problem, and at a distance of 140, the other distance 145. We use these dimensions. We select the same plane, XY, then F7, line with the length of 145. The level is 140. I want to be sure of where this line ends on the same vertical with the central point. This is our central point for this construction. Now I apply center line here, then dimensions. Lines, not dimensions. Line, line, here, and also this line. $150 is this. 16 here, and the diameter of 90. 90. Okay. Finish sketch, revolve, everything is prepared, and we apply join, not other options. Okay. Let's place here the fillet of 5 and also here 5. Good. Next is the volume inside with the vertical axis. Dimensions 138, 18 from this existent face, 115, 78, 70, and 26 and 7. Let's do this. There is another small element here, 5, radius 4, radius 4, diameter of 130. Good. Same plane, XY. F7, and we create that contour. I hope to respect every step here. To obtain the proper shape, not so proportional but acceptable. The last is this connection, then center line, diameter of 138, this is 130, 5 millimeters, and bottom is 18, as you remember. Then 7, then 26, no problem, it's outside, but we don't have problems because we place dimensions here. This diameter is 70, next one is 78, 78, and the last one is 115. Escape. This is all. This must be ignored so that I eliminate it instead of making construction line. Finish sketch, revolve, everything is prepared, only cut, not join, is necessary here. Okay, you like it? Yes, of course. Now a simple hole is here. Dimension is 70. We apply hole even if it is a large hole. That is the face, this is the center, and 70 is the hole, but we don't want it to go to this outside. This is not acceptable here. We can use as an end plane this plane or this internal face. I select internal face. Both use these two. Select surface, I select surface, and I hope to have I need to select also this because there are two steps, two possibilities here. Okay. Good? Good. There is a fillet right here of 4 millimeters, and another one is here which is also 4 millimeters, so that we keep them together Yes, not add using plus to apply another radius. Okay. Now we have to place holes. 1, 2, 3 patterns of holes. We start with this one. Diameter of 16, 6 holes, equidistant, on a diameter of 200. Okay. We select this face. We draw a line. We have a strategy here. We draw a line with the length of 200 divided by 2, because it's the radius. Then we place here a point at the end of this line, a point, but not this solution, the other one, because when you apply hole, I apply hole, that hole of 70. Oh no, diameter is 16. I write here 16, and I don't use 2, because there is nothing. We don't intersect this bottom shape, so that we go through. Yes, through, no problem. Okay. Then pattern, circular pattern of this feature about this axis. 6 is the default number, so this is finished. We go here. What is the definition? The definition is here. 120, yes, 4 holes, and 45 is the starting hole. 16 is the diameter. All holes are 16. Okay, you remember dimensions, yes? I select the plane, I apply a sketch, I activate the tool line, I draw a sloped line with the length of 120 divided by 2, and tab the angle of 45. Okay, okay. Then I place here a point. The default solution is this one, but I apply the point which has this option, and I disable that. Finish sketch, hole, and you see now directly a hole here. 16 is the diameter, but it is through, so that I select 2 and this face. The hole finishes here. Okay. Then pattern, circular pattern of this feature about this axis a number of 4, not 6. Okay, the last is this button with holes. When you look from this arrow B, you see this is B. 4 holes, diameter 16 on a circle of 125. Holes are placed in the cardinal direction, if I can say this. Line from the center to cardinal north of 125 divided by 2. We don't calculate by heart because the risks are very possible for mistake. I select the point, I disable this option, finish sketch, hole, and again I have 2 already selected, so that I activate this option to finish the hole here. Okay, pattern, this feature about this axis, and 4, not 6 instances. Good, almost finished. Let's apply material, which is steel cast, and the aspect to be a new one, gunmetal antique polished, and we select some faces, this one to be machined, this one, then inside 1, 2 and 3. I keep pressed the shift button key on the keyboard when I select something. All of them I want to be machined. What aspect? The aspect is titanium polished. You see? Now we have the final object. You can eliminate edges, shade it, and you have the same object like this one. Other light there from here, but the object is the same. Let me see what is the volume. Properties, physical, update, copy, and double click here. It seems to be identical, my friends. You see, this was not a difficult object, so that I expected to this. That's all for today. Thanks for watching. Bye bye. Now we have to finish this end. We take a look at the drawing and we see that here is a nice spherical end. Yes, I create this spheric by using again the basic sketch, of course. Visibility, F7, no, a new sketch in the plane XY. Eternal XY is used. Sketch, where is the mark sketch? Where are you? Sketch mark. Oh, I don't create a plane. The plane exists. Yes. A long day, my friends. We are tired. You and me as well. Look what I do here. I project this geometry and I hide the basic sketch. Visibility. Yellow is the projection. I draw a line as I create a circle. First, circle to the projection. Then I draw an arbitrary diameter. Arbitrary. This is a chord, and now it is a diameter when I make this coincident. I make this so, center line, and I trim half of this circle. And now I apply revolve and I have a sphere. But I want this to be different object from the base one, so that I select new solid. Okay, I select it, I apply properties and I make it red, my friends. Red is very well visible. This is different from the other one. Now I make it not visible, this solid not visible. Why? Because I have to create an extrusion based on this sketch. Extrusion. Ten millimeters is enough, but not with this as a base. Double click on the extrusion to make it new object. Okay, now I make visible the sphere and I combine this, but I select firstly the red. Combine the sphere with the extrusion and I apply intersect because I want to have only the intersection of the two. Okay, you see, it's okay now. I combine now this original solid with the last one. Combine, not cut, not intersect but combine. And I change this face to have the aspect cleared. This is only one object, of course.